All right, the last little bit of Chapter 7, just a reminder of how these graphs are transformed. Do they all work the same way? We'll step through them here. This is from 7.1, but I've got an example from 7.9 as well, just to check our thinking. But really easy. What is the general equation of a circle? X minus h squared plus y minus k squared equals the radius squared. Center is at hk. Radius is the square root of that number on its own. You can see here in an example, x minus 1 squared plus y plus 1 all squared equals 9. So my radius is actually 3 there. And if you check, if I just go across 1, 2, 3 units or up 1, 2, 3 units, you can see the radius is 3. And the center is going to be at 1 and negative 1. Remember, it's y minus k, so that's plus 1. It's actually shifted it down 1. When it's inside the brackets, the shift is in the opposite direction to the sign. That's the easiest way to think about it. So usually with x, when it's happening to just x, it's inside brackets or it's underneath, on top of a vinculum or under a square root sign, any of those. When it's grouped together, if it's just happening to one of the letters, it works in the opposite direction. When it's happening at the end of an equation, that's when it's shifting up or down in the same direction for y. But that one really easy. So I'd say the turning point, 1, negative 1, radius of 3. I put it in, I put those points, they're at right angles 3 away, and I'd join them up and I'd have sketched the circle. Exponential equations, a x minus h plus k. So again, here that h is tied up with that x, it's together with it in the index. When they're together, you could put brackets around it if you wanted to be really clear. That's going to shift it in the opposite direction to the sign. So minus h would actually shift it to the right by h units. Adding h would shift it to the left. Now, the beauty of these ones is you can't really tell when they're shifting right or left. It looks almost the same. It's still going to have that general shape. What's really going to happen is the intercept might be higher up on the axis rather than being here at 1, but it's the same procedure. Same general shape. If I multiply by negative 20 of these, what happens? Reflected in the x-axis, turn it upside down. If I multiply just the x, if I put a negative just in front of x, reflected in the y-axis. You should play around in Desmos to check that out, just to get used to it. Here the k value, that's the vertical shift. In this example, they've added 1, so the whole thing shifted up 1, and now I've got that asymptote at y equals 1. But it's really easy. Finally, the hyperbolas we've already looked at. Here it was x minus h plus k. If I've got x minus 2 plus 1, it shifted up 1, and it shifted to the left, to the right 2, because it's in the opposite direction to the sign. So there's my x equals 2 is my vertical asymptote, y equals 1 is a horizontal asymptote. Remember that vertical asymptote? If I substitute that number in, that'd make the denominator 0. That's why we can't get an answer there. The reason it can't equal 1 is because that fraction can never equal 0, so the whole thing can never equal the number on the end of 1. It's that easy. You can just write that down on your summary sheet with the example there. You basically copy that out. You'd be fine. Let's have a look at some of these easy things. Matching the equations with the graphs. You know we did this in every exercise because it's a really good skill to do. How do we recognize these and what do we match them up with? Let's use our beautiful highlighters again. Well, this one here, that's a wonky line is what that is. Seems to be a bit, I was drawing with a pen upside down. That's why it was a bit delayed. What do we notice about that? That's a circle. There's only one circle there. It's got an x squared and a y squared. So that wasn't too hard, was it? All right, what about the next? What else have we got here? 2 to the power of x. So that's going to be an exponential equation increasing like that. Oh, well, there's only one of those. That looks like it's d. Now, I forgot to change the color there, so let's use a different color. Let's make that one blue. Doesn't really matter which one we start with. We can see pretty easily what they're going to match up with while we're moving at random. Let's go with y equals 4 divided by x. So this is a rectangular, this is just a hyperbola in that sort of shape. Okay, we know that. It hasn't shifted up or down, so the asymptotes are going to be the axes. Looks like that's got asymptotes that are the axes. Hasn't been reflected or anything. And you can even check the point when x equals 1, y would equal 4, so that's correct. The green one, y equals negative 1 over x. What does that do? The negative reflects it in the x-axis. It's been turned upside down. So instead of having bits going like this, when I reflect that, they end up with that sort of shape. Not the best to demonstrate with the green highlighter, but we can see what we're looking for straight away is going to be that one there. It's a hyperbola where it's been reflected. X in the denominator. That's your clue that we're looking for that sort of shape. We need a couple more highlighters here. There we go, let's find that one. An orange one. Y equals a half x plus 1. Oh my goodness, that's a straight line. That's way back to grade 8 and 9 maths. Gradient of a half, up 1, across 2, plus 1, really easy. Final one. What do we got there? We've got another colour, we've got a different purple. Slightly different purple. Can you even read that? Maybe not. 3 to the power of negative x. What happens there? The negative x means it's been reflected in the y-axis. Negative power, as x increases, it's getting closer and closer to 0. So you can see why it would have that shape. They're all pretty straightforward, nothing too complicated there. Now let's just get our regular pen back, because we're going to go down here and do maybe even slightly more complicated thinking. Find a rule for each graph. Well, let's go ahead and see if I can do this. Now I know it's x minus the x-coordinate at the turning point, so that'll be x minus 2 squared plus y minus 1 squared equals r squared. Now I've got to figure out what that radius is. I could use my distance formula. You can see I could make a right-angled triangle there, and that's gone 2 across that way and 2 up that way. Pythagoras' theorem would tell me that 2 squared plus 2 squared would be 4, and 4 would be 8. So this side would be root 8, which would be the same as 2 root 2. But given that I square it over there when I get r squared, I can just make it x take 2 squared plus y minus 1 squared equals 8. And it's as simple as that. Here I've got another circle. Let's have a go at this one. X, the x turning point is at negative 2, so minus negative 2 is the same as plus 2 squared. The y value, the y coordinate, it hasn't shifted up or down, so I don't need to have anything in the brackets with the y, it's just plus y squared equals the radius squared. Well, how far away is that point? What's the radius this time? Well, that horizontal distance there from negative 2 across to 2 is 4 units. The vertical distance is 3 units. You all know Pythagoras' theorem that that's going to be 5. So when I write it over here, I've got to write it as the radius squared, 25. So x plus 2 all squared plus y squared equals 25. Not that bad. Another one there. We don't really want to do another circle. I assume you can do it all by now. Let's have a look at this one. It's a hyperbola. It hasn't been shifted anywhere in particular. So I've got y equals, well, it has been shifted, but it hasn't been reflected, is what I was trying to say. You can see I've been doing these for too long now. Let's have a look. So I don't know what value to put in for a yet, but I know that it's going to be x minus 1, because I've shifted the asymptote, the vertical asymptote across 1, and then it's also shifted up 1, so it's going to be plus 1. Now if I sub in the point that I've been given, 0, 0, that will let me determine the value of a. So let's have a look. 0 equals a over 0 minus 1 plus 1. Subtracting 1 from each side, I get negative 1 equals a over negative 1 multiplied by negative 1. Oh, well, in this case, a is equal to 1. So my equation is just y equals 1 over x take 1 plus 1. And that will give me that graph there. Let's have a look at the last two. I think we're getting the hang of these now. So I've shifted, where have my asymptotes shifted? They've gone down 1 and across 2. So y is going to equal something over x plus 2, because it shifted to the left and it goes in the opposite direction. But when I'm adding the number at the end, I just do it in the same direction. So minus 1. What's a point that I know? They haven't actually given me a point for this one anywhere, have they? So I'm going to assume that they're being nice and not making us figure out what a is. So it's going to be 1 over x plus 2, take away 1. Here's one where they have given us a point, so that might help us a little bit. Let's see if we can do this one. So again, what do I have? I have y equals something over x, and which way have I shifted? I've shifted to the left by 3, so it's got to be plus 3. Adding 3 shifts it to the left 3. Check it. If I put in negative 3, the denominator 0, it would be undefined. That makes sense. It hasn't shifted up or down, so I don't need to actually do anything in terms of adding or subtracting. You can see the x-axis is still my asymptote. So now all I need to do is sub in when x equals 0, y equals negative 1/3. So here I've got negative 1/3 equals a over 0 plus 3 is just 3. Oh, that's pretty easy. Negative 1 equals a. So I've got my equation. Y equals negative 1 over x plus 3. That's shifting equations. What I encourage you to do, go to Desmos if you really want to get a handle on these. Oh, that's probably not the way to do it. Let's see if I've got Desmos open in this one. Yeah, look, I've got Desmos open over here. That'll do. Get a handle on these. Just have a play with them. Y equals, what do we have? A divided by x plus h. Oh, it's talking to me. I don't know if you can hear that or not. Plus k. Stay on this page, please. And there we have. We can add sliders to each of those, and you can see the effect. So usually we start off with h being 0, k being 0, and we'll leave a as 1 because it's a multiple. You want to actually leave that as 1. Now I might need to get my ugly mug out of the way here. Well, don't know how to. Let's just move me around, see if that helps. Hopefully you can see the screen clearly enough anyway. If I increase h, what's going to happen? It's adding h, so it should go in the opposite direction. It should shift it to the left, and you can see that happens. If you want to be really fancy, you can put in the equation x equals h here, and you'll see that the asymptote is moving as well. Oh, we need x equals negative h. That's better. And you can see where the asymptote is. You can even go ahead and edit these and make them dotted lines if you want, like that. And there you can see your asymptote there. Same with the y asymptote. You can just put in y equals k, get that asymptote, and again we can change that by using the dotted lines. Don't you like how it's talking to us? I'm not sure why that is. But there you go. As I shift it up or down, when I look at that equation now, y equals 1 over, this would be x plus 3 plus k was 2. X plus 3 plus 2, does it make sense? Yep. Plus 3 shifts me to the left by 3. Plus 2 shifts it up by 2. Get the general shape. Pretty straightforward. They will always intersect at the values that you're given. I'm going to sneeze, so I'm going to pause and say good night. Have a play on Desmos. Good luck with your study. I will see you soon. Keep the questions coming. If you've got any, I should have a chance to do some tomorrow. But remember that on Monday I will be away at Ironbark, but I will, of course, answer some questions when I get back. Happy studying. Cheers, guys.